I'm Andrei Popa, and I'm a security engineer at Garden Computing. Today, I'll show you how we tackle the challenge of creating practical local-first permissions in Jazz, our framework for building local-first apps. Jazz is open source, and most importantly, very batteries included, giving you not only share state with instant updates, but also permissions, auth, file uploads, and more. Plus sync and cloud storage is completely solved for you, easily self-hostable or zero setup with Jazz Cloud. The way you build apps with Jazz is using what we call CoValues, short for collaborative values. These are our CRDTs. You can build your whole app with CoValues and use them for both structured and binary data. For example, for JSON-like data, you can use comaps and colists. For presence updates, you can use cofeeds. And for handling files, you have file streams. And there's more on the way, like co-plain text and co-rich text, which are obviously really important for collaborative apps. So, CoValues give you this magical shared state that makes it super easy to build local-first apps. But we realized that just having shared state isn't enough. You also need permissions that are as local-first as the shared state itself. Otherwise, you can't make full use of these nice properties. And most importantly, implementing user accounts, permissions, and auth will be quite tricky and something you would need to do by yourself. This is why, in Jazz, user identity and permissions are baked into CoValues at the protocol level. And I'd like to show you in detail how that works. But before I can show you how exactly permissions work in CoValues, I need to explain how CoValues implement just the shared state part, because permissions will build on that structure, on top of that structure. So let's take a look at the anatomy of a CoValue. A CoValue is made up of two key parts. The first part is the header. The header includes properties like the type of CoValue, such as comap or colist, and the owner ID, which we'll get into that later. The header itself is immutable, which means that we can refer to a CoValue by the hash of its header, which we call a CoValue ID. But the most interesting bit of a CoValue is its second part, which makes it dynamic. CoValues have a set of append-only logs, one for each account session participating in the CoValue. Each append-only log records all the edits one participant has done to the CoValue. And remember those primitives I mentioned earlier, comap and colist? They're essentially just views built on top of this history structure. As you can see, each of the entries has a timestamp associated with it, which will help us agree on an order to look at entries across logs. For example, for a comap, the entries of the append-only logs would be set or delete operations with a key and a value. And you can get the current state of the comap by finding the newest in-time entry for each key, which is also known as last writer wins. And for a colist, for example, the entries would be append after or prepend before operations with list items. So this is simple enough, right? So next, I'd like you to take a second and imagine how you would implement sync for CoValues based on this structure. As you probably guessed, the nice thing is that you only need to exchange the header of a CoValue and any missing entries in the append-only logs that different peers might not know about yet locally. And eventually, once all history is reconciled, they will automatically arrive at the same current state for the CoValue, which makes them eventually consistent and a CRDT. The fun thing is that persistence is actually exactly the same problem as syncing. You're just syncing with your hard drive. And in Jazz, we actually use exactly the same syncing protocol between peers and local storage, which is also modeled as a peer. So we saw how the anatomy of a CoValue lets us implement shared state that can be synced and persisted in a really straightforward way. But what's even better about this structure is that it's actually really easy to add permissions on top. So let me get into that. So let's start with verifying data integrity and verifying the author of each change. We can do both by calculating a rolling hash in each append-only log over each entry. The user writing to this append-only log then signs the resulting hash, which verifies the integrity of the entire log, preventing tampering and reordering. And we get cryptographic undeniable proof that the content of that log was actually made by that user. And when the user wants to add more changes, they just update the rolling hash with those and resign the resulting latest hash. This design lets us verify an entire log by just checking one signature, no matter how long the log is. So this already gives us almost everything we need to implement write access control. So now let's take a look at how Jazz handles read access control. The idea is really simple. We just encrypt the content of each log entry with a key that we share with other participants. Similarly to the rolling hash, we can make use of the fact that these are append-only logs and simply use a stream cipher. This offers low overhead encryption when adding new entries and efficient decryption of even long edit histories. And this is how we solve read access. So let's recap and see how hashing, signing, and encrypting work together. Hashing detects tampering with data, like if altered, the signature verification over the hash will fail. The signatures will also verify the identity of the author, confirming who created the data in a non-deniable way, basically giving us a free audit trail as well. Lastly, encryption ensures that only authorized users with the correct key can read the content, keeping data confidential, even if it's intercepted or stored on untrusted servers. So hopefully, the only questions that you might still have are, how do we orchestrate key sharing? And how do we know which verified authors are allowed to write to a CoValue? And this is where groups come in. Groups are the key abstraction in Jazz to implement role-based permissions. The important detail here is that each CoValue is owned by a group. The group acts as a scope for permissions. First, groups maintain a map. Cheers. First, groups maintain a map of account IDs to roles like admin, writer, or reader, which define what operations members can perform on CoValues owned by that group. Groups also maintain a read key, which is the current encryption key used to encrypt log entries in the CoValues it owns. So based on that, here is how we can dynamically add or remove group members with roles. When adding a new member, their role is set, and the group key is revealed to them, encrypted specifically for their public key. Only they can unseal it. When they start writing to CoValues, everyone else can verify locally that they have the correct role in the group. Now, if a member is removed, their role is unset, and the group generates a new key and shares it with all the remaining members. This means the removed member loses access since they can't decrypt new content without the updated key. One thing that you might have noticed is that groups actually look like a map, and we need to sync and eventually agree on the content of that map, which sounds a lot like a COMAP. Groups themselves are COMAPs, or more specifically, a special kind of COMAP that stores member roles, read key ID, and revelation of the read key for each member. This design brings several key benefits. Groups inherit CRDT properties like eventual consistency, local first changes, easy syncing, and persistence. And of course, the changes to the group are cryptographically verified as well. But the best part is, even though I'm sure you understood all of that, you actually don't need to know any of it to use Jazz, because the API for using CoValues with groups to set permissions is really straightforward. For example, here, for a simple chat app, first, we create a new group owned by the current user. Next, we add Bob as a writer to the group. Finally, we create a new chat co-list owned by the group. This means that only me and Bob have the ability to read and write to it. That's how simple it is. And you can do all of this on the client side, which means that you can write whole multi-user apps using only front-end code if you want. One last thing, you might be wondering now where the users and their cryptographic key pairs come from. This is solved by auth methods in Jazz, which are easily pluggable and handle all the state management around sign-up and login. Jazz has several auth methods built in, such as demo auth, which lets you try out collaborative apps as different users really quickly, passkey auth, where users manage their keys themselves, but with a really nice Touch ID or Face ID user experience, thanks to a hacky way we use browser passkeys. And for more traditional setups, we have clerk integration with more similar ones to come. And it's also quite easy to build your own auth method. For example, to integrate with existing auth and permissions you have in your own database or in an existing backend. Finally, I just want to mention a feature that just landed that makes groups even more powerful: group inheritance. Group inheritance lets you build very complex permission structures easily. For example, if you want to build something like Notion, you want your team to be able to access every page, but then you also might want to ad hoc share individual pages with additional people. Group inheritance lets you express that and build the UI for it really easily. So, if this sounds cool, please check out jazz.tools to learn more how to build apps with CoValues and groups. We've got lots of examples for inspiration, and the docs are getting better every day. If you have any questions or want to show us a cool thing you're building with Jazz, please join our Discord. If you do build something cool, we also get these nice holographic stickers for you. But before we finish, I've got one more thing. I heard that you like CRDTs. So what if we store diffs of other CRDT libraries in this CoValue structure? We would get local first permissions, sync, and persistence for free, but also compatibility with the entire ecosystems around these libraries. And we could even mix and match within one app while having one abstraction for sync, storage, and permissions. And we can do this for YJazz, for AutoMerge, and for LoRa. So today we are announcing YJazz, AutoJazz, and LoRaJazz. And if you're curious, here's the link to the proof of concept. I hope this was interesting. Thank you so much.